So we got basic problem 9-2, and that's what you guys are assigned. And so I'll just give you a couple of examples of how to do this using Excel. It's extremely easy using Excel. It's kind of a cool thing. So we're going to find that there's some functions up here that we can use, and what we'll find is typically a lot of these things repeating, and there'll be at least 4 of them, or at least 3 of them, and if we have 3 of them, we can always find the 4th, I like to say. And in this case, we're going to be dealing with present value. I'm hoping that we'll look at some others that are going to be future value, and it sure looks like we will. So why do we do this? Why do we care what the present value is of something? And in this case, we're looking at a single dollar amount. And I kind of like to think of it maybe a little bit backwards. We're saying, well, if I'm going to get $10,000, that's my example here, in 20 years, and I'm using a 9% discount rate is often how that's expressed. Okay. This is how much it's worth today. Okay, and I could use that to make some comparisons and whatnot, but I like to look at it a little bit backwards and say, okay, now if I invested this much, if I wanted to have, let's say, $10,000 in 20 years, and I thought I could earn 9% interest, how much would I need, or 9% return anyhow, how much would I need to invest now? And the answer would be this. Okay. So let's go ahead and calculate a couple of these. And again, you guys have 3, an A, B, and C. I think I just did 2 here, and that's fine. And I just did some different numbers. I said, if I've got a future value, okay, and that's what your guys' is, the numbers that they give you, the dollar numbers that they give you are called a future value. So let's label it as such so we don't get these confused ever. And then the number of periods, and in this case we'll use annual because that's how you're going to calculate it. You'll find as we go along we're going to break these down, maybe here even in chapter 9 or in later chapters, to some monthly ones and quarterly and different periods, but for this purpose we can use just an annual. So let's say it's 20 years, and my rate then per year is 9%. Okay, if we were going to do monthly, okay, then I'd have to have a monthly rate as well, but again, we'll worry about that in the future. So I'm solving, and it's asked for, what's the present value of. So let's hit our function key up here, and let's go to financial, and then let's see if there's one that's called present value, or PV. Surprise, surprise. Returns the present value of an investment, the total amount that a series of future payments is worth now. So it could be future payments, but it can also be just a future amount. Okay, so if you'll notice here, it gives us 1, 2, 3, 4, and really 5 fields that we could fill in, but we only need 3 of them. Payment we don't have, and so we're going to leave that blank, and that's fine. We'll use that later. Okay, but we won't fill it in now. So now it's just a simple matter of, okay, and this is how I like to do it. You could actually input the numbers right in this field. You could say, well, 9% is 0.09. Okay, but it's easier just to, if you're looking for rate, come and click on rate. Okay, and then click on your number of periods, and you hit that one. Again, we don't have a payment, but we do know what our future value is. Okay, and type is logical. Payment at the beginning of the period equals 1. Payment at the end of the period equals 0 or omitted. Okay, typically we're going to leave this blank, but there will be some times, especially when we do future value calculations, where this may be important. But I think for all intents and purposes, for the most part, if it doesn't say anything, that would lead you to believe or lead you to say it's at the beginning of a period, leave it blank. Okay, and you'll see it tells us what our answer is, and it says it's going to be minus $1,784. And I guess the way I like to look at that is that's what I'd have to take out of my pocket. Okay, so if I were going to make an investment, You know, why they do the minuses and the pluses, I'm not 100% sure, but this is what I'd have to take out of my pocket and invest today if I wanted to have $10,000 in 20 years earning 9% interest. So, okay. The other example that I gave was this. $1 million. What if I wanted to have $1 million, but if I were simply 20 years old and I wanted to have $1 million when I was 65, if I could make one lump sum investment, okay, that would earn 18%, how much would that investment need to be? Wow. Okay, let's calculate that. Does that $582 seem even possible? You know, 1784 only gives me 10 grand. Of course, that's at 9%. Yeah. Well, let's go up and figure it out here. So we can use most recently used now. Present value. Okay. My rate's 18%. What this is really going to demonstrate is the power of compound interest and high returns. And by the way, Berkshire Hathaway, you guys will hear me speak about Berkshire Hathaway over the last 50 years, has had a compounded annual return of over 20%. I think it's fallen off the last couple of years. It hasn't been quite as good, and it probably is down closer to this 18%. So had you invested in Berkshire Hathaway 50 years ago, even $500, okay, well, or whatever we come up with, but I think that's what it's going to be, okay, you would have, yep, if you'd have invested $582.52, okay, and left it in there for 45 years, you know, at the age of 20, so at 65, yeah, you'd have $1 million, okay. That seems kind of hard to fathom, but it's very true. 18% is a good return. You know, you'll seldom see companies that will give you that kind of a consistent return over a number of years like that, but they are out there. You know, imagine if you made 10 investments. You know, if your grandma gave you $5 grand or $6 grand, right, and you made 10 investments in 10 different companies, if even just one of those, you know, did that well, and maybe the other ones less well, you know, think how much money you would accumulate in that period of time. So there you have some present value calculations.